Hey everybody, welcome to Other Landscape Maintenance Activities, Part 1 of 2. In Part 1 we will talk about water usage, root zone aeration, and root collar excavation. In Part 2 we'll talk about tree and shrub fertilization and tree injections. So let's go ahead and get started. We'll start out by talking about watering. So think of all the factors that play a role in watering plants. So one factor might be the plant species itself and what its water requirements are. Another factor would definitely be the type of soil that the plant is growing in. A third factor could be the percent relative humidity, the wind speed, the temperature, previous and future rainfall. So all these things play into whether or not you need to water your plant. So it's very difficult to come up with a patented prescription for how much you should water a plant. Earlier in the class we talked about the importance of plant selection, and we said that all good landscaping starts with good design and proper plant selection. Choose plants that are adapted to your location. So this is all good to remember. One article that I read suggested that when you design your landscape, you might consider putting species of plants that are high water usage plants together in one area of the landscape, and then moderate and low water usage plants perhaps in other areas of the landscape. So let's talk a little bit about why plants need water in the first place. Plants require water for photosynthesis. If you think back to the reaction, plants need light, carbon dioxide, and water, and from those three things they're able to make sugar and a form of chemical energy called ATP. Plants lose water during a process called transpiration. So a large tree, and we're talking about a fully grown oak tree or a maple tree, can absorb hundreds of gallons of water each day, and as much as 95% of that water can be lost to transpiration. So let's put that in context for a second. So if you think of a tree, let's imagine that over the lifetime or over its lifetime, the tree absorbs 10,000 gallons of water. So what we're saying is that out of that 10,000 gallons, 9,500 gallons are lost to transpiration, and only 500 gallons are actually retained by the tissues, the living cells in that tree. So plants, especially large trees, transpire great quantities of water. When transpirational water loss exceeds root absorption, the leaves may scorch and or wilt. This is Japanese maple, and if you look at the margins of the leaves, you can see that they're downturned, they're kind of a brown color. There's obviously dead tissue along the margin, so this is what we call leaf scorch. And this is one indication that perhaps your plants aren't getting enough water, or possibly you took a plant that preferred to grow in the shade and put it in a full sun location. Leaf scorch can occur under both those different scenarios. This is an interesting diagram that shows how different soil types can affect water percolation. So water percolation refers to the movement of water through the soil profile relative to gravity, or gravitational pull. So if we look at the soil type on the left, you're looking at a sandy soil, and if that soil were saturated and then allowed to drain, so after 15 minutes of time, the water would have drained down to the 12-inch depth. A little over 40 minutes, you're down to the 36-inch depth, and within an hour that water would have percolated all the way down to 60 inches or more of depth. Over on the right, you're looking at a soil that's high in clay, and you can see that the movement of water by percolation is different. So the water tends to spread out laterally across the soil profile, and that is a function of capillarity or capillary action. So after about 4 hours, the water's only gone to a depth of 24 inches. After 24 hours, the water is only moved to a depth of 36 inches. So you can see the difference between the two different soil types. The term establishment refers to the period of time required for a plant to overcome initial transplant shock and establish its root system. So the amount of time it takes a plant to become established after transplanting really depends on the type of plant and the production method that was used to harvest that plant. So for example, annuals and herbaceous perennials, they can become established in a few weeks. Shrubs may take several months, and trees may take a year to several years before they become fully established, especially if the tree was harvested in a balled and burlap method where there would be substantial root loss during the harvest process. An additional problem that you may encounter is a textural problem related to the textural differences between the soilless growing medium that a lot of our trees and shrubs are growing in today, and that soilless medium consists of things like sphagnum peat moss, bark, perlite, and other ingredients. So there's a textural difference between the medium that the plant is growing in and the texture of the soil that the plant is planted in. When a soilless medium dries out, it can be difficult to re-wet. And plants that are growing in soilless mediums may need to be watered several times a week in the landscape after they've been planted. So this diagram attempts to illustrate what we're talking about. So imagine that you have a plant that was grown in a coarse textured growing medium. So the growing medium is soilless, it's well drained, and it has a coarse texture. And that plant was placed into a soil that has a very fine texture, maybe a clay soil, for example. So what happens is, in some cases, water does not easily move from the fine textured clay soil into the coarsely textured growing medium. So even though you're applying water, the water isn't actually getting into the root ball. So the plant essentially is not being watered even though you think you're watering it. So how to remedy a situation like this? Well, one solution is to not cover the top of the root ball with additional soil, and make sure that the mulch is pulled away from the trunk of the tree or the stems of the shrub. So when you water, the water can move directly into the growing medium that the plant was growing in. After the roots move out of the growing medium into the surrounding soil, then this isn't a problem anymore. So this picture shows the dry spots in a soilless medium that can lead to uneven wetting. So one thing manufacturers do to help correct this problem is they add wetting agents to the medium to correct the problem. So how much water is enough? Overwatering and underwatering are both equally bad. And as I mentioned earlier, it's impossible to come up with a schedule that fits all plants. At a minimum, a new shrub or tree will need to be watered at least once a week. Less water is needed after the plants have become established. Annuals and herbaceous perennials may require more frequent watering simply because their root systems are more shallow and the upper layers or upper several inches of the soil are going to dry out very quickly. So we may need to water annuals and herbaceous perennials more frequently. So when watering is done, deep watering is preferable to frequent light waterings. So the moral of the story is let the soil dry out a little bit before you apply additional water. And when you do water, water thoroughly, water deeply, and then let the soil dry out again before you water again. So sometimes it's just a matter of inspecting the soil rather than the plant. And this means getting down on your hands and knees and kind of moving the mulch out of the way and then using your fingers or a trowel or something to kind of dig into the soil to see how dry it is. So if you're digging into the soil and you see that the soil is moist right to the surface, then you probably don't need to water. But if you're digging in the soil and you see that it's pretty dry in that top inch to 1.5 inches, then you need to water. If you can, avoid getting the foliage wet. And this is simply because wet foliage can lead to different foliar diseases, especially those diseases caused by fungi. The spores, the fungal spores that are on leaves require a film of water before they can germinate and infect a leaf. So if we can keep the leaves dry, we can help manage foliar diseases on plants. But I know that sometimes this always isn't possible. You know, people say water in the morning so that your plants have the afternoon to dry their leaves off. Well, that's great if you can get out there and water in the morning, but sometimes we can't. But anyway, it's just something to kind of keep in mind. Keep the foliage dry if possible. Remember that the three conditions under which transpiration is maximized are as follows. So hot temperatures, so high temperatures, so above 90 degrees, that's very warm. Transpiration increases as the temperature increases. Dry soils and or low humidity. So if the humidity is very low, then the rate of transpiration is going to increase. And windy. So the rate of transpiration always increases as the wind speed increases. So the perfect trifecta for plant stress are hot, dry, windy conditions. So those are days where you might have to get out and water a little more than normal. Another consideration is transporting plant material, especially plant material that is in leaf, from the garden center where you purchase it to the landscaping site. So plant material should always be protected from the wind while being transported. So that means you need to cover the plant material with a tarp like you see in these pictures. And even if you're driving a relatively short distance, it's important to remember that if that plant, that shrub or tree or whatever, has leaves, and if you're driving down the road at 60 miles an hour, it's like a 60-mile-an-hour wind is, you know, causing the rate of transpiration to increase from those leaves. So those leaves are going to be losing a lot of water. All right, let's talk about another plant maintenance activity called root zone aeration. And one type of root zone aeration is referred to as vertical mulching. Vertical mulching is a process that works for both trees and shrubs. And during vertical mulching, holes are made in the ground either with a drill or an air tool like an air spade. After the holes have been made, they can be filled with a mixture of native soil and compost. Some people also add fertilizer and or mycorrhizal fungi to the mix as well. So this is an example of a steel power head with a soil auger that you could use to make a hole. And you can buy various size augers depending on the size hole you desire to make. This is an example of an air spade, and we talked about air spades earlier in the class, but you can do vertical mulching with an air spade as well. Okay, so this is what it looks like. So here's two trees that have vertical mulching accomplished around them. And you can see that the holes are spaced a couple feet apart. And I would imagine that the holes are going to be drilled down to a depth of about 6 to 8 inches or so. And then you're going to fill those holes back up with essentially a better soil. So vertical mulching is something that you don't have to do all the time. You would use it in situations where the soil was compacted or very hard and there wasn't good air and water infiltration into the soil. So really, vertical mulching isn't that much different than core aeration of somebody's lawn followed by top dressing. It's the same principle. So you're making a hole and then you're filling that hole with a better soil than currently exists on site. Let's talk a little bit about mycorrhizal fungi. I'm sure most of you have heard this term before, but these are beneficial fungi that develop a symbiotic relationship with the roots of plants. The fungi colonize the root system of a host plant, and they provide increased water and nutrient absorption capabilities, while the plant provides the fungus with carbohydrates formed during photosynthesis. So it's a symbiotic relationship. It benefits the plant, the host plant, but it also benefits the fungi. So this is an example of a product that's used in vertical mulching. It is a fertilizer that has mycorrhizal fungi in it. So you could add this to the soil mixture that you're going to use to refill the holes with. So all plants, not just trees and shrubs, even turf grasses, can benefit from the addition of mycorrhizal fungi. Now, in a native stand of timber that hasn't been disturbed, there's going to be mycorrhizal fungi present, and most of the trees and shrubs and plants growing in that forest environment are going to have mycorrhizal fungi associated with their root systems. The problem is in landscaping situations where the soil has been disturbed, that's going to damage the population or eliminate the population of mycorrhizal fungi. So if we want the benefits of mycorrhizal fungi, we have to reintroduce them into the soil. But turf grasses benefit as well from mycorrhizal fungi. So this picture illustrates turf grass on the left that do not have mycorrhizal fungi associated with their root systems. And then on the right, you see the mycorrhizal fungi in yellow, and you can see the enhanced root system and vigor of the plants as a result of that relationship. Radial trenching is something that we also discussed earlier in class. It's a procedure that can be done to both shrubs and trees. And trenches are made in a radial pattern throughout the root zone of the tree or shrub. And those trenches extend beyond the drip line of the tree or shrub because remember, the root system will also extend beyond the drip line of a tree or shrub. After the trenches have been made, they can be backfilled with a mixture of native soil and compost. And of course, if you desire, you can add fertilizer and mycorrhizal fungi to the mix as well. Okay, so this is an air spade in use around a tree. So we're doing radial trenching around this tree. So this tree was selected for radial trenching because the soil that the tree was growing in was compacted and there was not good air and water and nutrient percolation into the soil. Okay, this is a different tree after the trenches have been created with the air spade. And here is yet another tree. You can see the radial trenches, and you can see at this point they've been filled back in. So you'll notice over time that the roots of a tree like this are really going to like growing in those trenches. So if you were to come back maybe 5 years from now and kind of excavate in the area where those trenches were made, you would see a lot more root growth in the trench than outside of the trench. That's because the texture is better, the water holding capacity is better, and probably most importantly, there's oxygen there for the roots. All right, yet another job that landscapers might have to perform is correcting improper planting depth. And this procedure is called root collar excavation. And it is accomplished with an air spade. That would be the tool of choice. So you would be using the air spade to locate the root collar. And the root collar is just simply the place on a tree where the roots and trunk come together. That particular place is called the collar. Soil can be removed to correct for improper planting depth. And earlier in the class we said there are many trees that have been planted too deep. And one of the telltale signs is you look at a tree that's maybe 20 years old and it looks like a telephone pole stuck in the ground. So you don't see any root flare, and the root collar is actually below grade. So that's a problem. It's not going to kill the tree immediately, but it will shorten the lifespan of that tree. So what can you do to correct it? Well, you can use an air tool like an air spade to remove soil and try to locate that root collar. So that's what's being done in this picture. You can see the operator using the air spade to locate the root collar. All right, so here's a tree that was planted way too deep, and you can see how much soil had to be excavated to find that root collar. So now you've created this basin. So you solved one problem, but you've created another problem. So what are some of the potential problems with this basin? Well, one problem that comes to mind is just drainage. So if that soil is not a very well drained soil, that basin is going to fill up with water, and that root system is going to sit in that saturated soil. And that's not going to be good for the root system over time, because remember, those roots need oxygen. So one possible solution might be something like, at least this would make it look maybe more aesthetically pleasing. So after you locate the root collar, then you can build a low retaining wall kind of around that bowl-shaped depression, and perhaps put some French drains into the bottom of the depression to help drain some of that water out. So this could be a potential solution. All right, this is the end of part 1 of 2. Thanks for watching.